past 12 to 18 months, like no point in my previous 20 years involvement in open source, has really driven home just how pervasive and ubiquitous open source has become. Open source is truly everywhere. And I know that it's in my watches. I know that it's in the cars that I drive. It's the washing machine in my house. And of course, all over the software on the computers that we operate. I've known that, frankly, for 20 years. I knew that open source was everywhere, that it was important. And of course, open source is important to AWS. We build tools atop it. We build services atop it. Our customers love it. And so we've got a vested interest in the broader security of open source in the landscape that we operate in. But as I said, the past 12 to 18 months have been really a huge change in people recognizing just how ubiquitous it is. And so Synopsys, who provide the Black Duck software composition analysis tool, they're telling us that 96% of code bases that they see contain open source. 96%. I've always known that open source has been ubiquitous, but 96%? So I want to spend some time talking about open source, how AWS thinks about it. I want to say that it's not just important, but talk a little bit about why it's important and how we engage in open source communities. I think the why is important because it probably applies to most companies. And I want to explain our commitment and our strategy. AWS has this long history of benefiting from open source. AWS would not look like it does today without open source. If you'll remember EC2, it was built atop the Xen hypervisor. S3 was originally built atop Apache Tomcat. They were the foundational layers that allowed us to innovate quickly and deliver value to our customers. And we think that open source is much better in terms of being able to provide those foundational layers that allow us to innovate and deliver value. No one wants to reinvent the wheel and write another web server. We have a number of very good open source web servers that allow us to not have to spend the time to re-implement that. Of course, that means that we need to have a very healthy, a very sustainable open source foundation to build atop. And healthy means a couple of different things, right? We want secure code. We want well-tested code that operates well. We also want the communities that are building that code to be sustainable and to be healthy. We don't want the one person in Nebraska holding up the entire internet. And so when we're looking at how we pay attention to open source, we recognize that it's important to our business, it's important to our builders, and we build, obviously, plenty of things on top of it. But it's not just important to AWS, it's important to our customers. Many of our customers tell us that they have open source first mandates in their business. Meaning that when they're choosing a new technology platform, that they are defaulting to open source if one is available. And so with customers repeatedly choosing open source, asking us to help with their open source workloads, and whether that's a database server, whether it's AI, ML platforms, or container orchestration engines, we have to make sure that those workloads run really well on top of AWS and for our customers in general. Open source also is important to the world. It has become a common foundation that we're all dependent upon, which means that we have somewhat of a shared destiny because we're all depending upon open source, because open source is ubiquitous. We have a lot of conversations. Mark and I get to speak to customers frequently, and customers are continuously asking us, Tell us how you think about open source. How are you securing your supply chain? We're having lots of software supply chain security conversations today, and that really comes down to two questions. The first is, how are you consuming open source safely? What constraints are you putting in to make sure that open source is being consumed in a responsible manner? And then also, how are you taking care of the software development process to ensure that all of these things that you're ingesting are secure? And people are lumping both of those things into our software supply chain security conversations. And so we want to talk a little bit about that as well and show you some of the things that AWS is doing. May not be a perfect fit for other folks, but at least it'll be very transparent in how we handle open source and how we think about that process. Mark, do you want to talk about some of those conversations?
Yeah, good morning, everyone. It's great to be here. This presentation is very broadly about how AWS works with the open source community to make it stronger, healthier, and more secure. But we thought it would make sense to at least briefly talk about how we consume open source, and that conversation, although a brief part of this overall talk, we could do a whole hour just on this topic, will at least give you some thoughts about both how we operate, but thoughts about how you as well could operate. There's not one perfect way to do this, but we think we have some learnings we'd like to share. So just briefly, in terms of secure consumption, we very much take a federated approach to this topic, as we do with many other topics. We don't highly centralize really anything at AWS, but we still have central teams that support certain core functions to make sure that the teams that have sort of direct or immediate responsibility are doing their job well. And for us, open source consumption begins in the engineering teams that decide to use open source. So the consumers of open source take that core responsibility for the software artifacts they're using. Whether they develop them themselves or whether they import something from the outside world, it's their responsibility to do that in a safe, sane, and secure fashion, with the support of a bunch of other teams, but still, the core responsibility exists in that initial consumer. And in order to make sure that we have ownership of these artifacts once they're brought in, we place that responsibility on sort of that initial consuming team. They can hand it off later, perhaps, if that makes sense, but some team has to really own the health and maintenance of that core library or what have you, and that's the builder team. They need a lot of support to do that well, and that's where our builder experience team, which is a central team, comes in. This is the team that runs the core code repositories, build servers, build pipelines, as well as all of the deployment capabilities, and a lot of centralized testing that runs on every single code check-in, everything from unit tests and so forth, but security tests and code scans, static code analysis, software composition analysis, all these tools are run in a central service fashion by the builder experience team. So that means that any other organization that wants to use this say an open source library, the first thing they're going to do is they're going to look to see, hey, is anybody else using this? Just like they would want to reuse code that's internal only, they're going to want to reuse open source code as well, because that means someone's taken initial responsibility for vetting, maintaining, and updating that system. And so this is where that other team would go to the central code repository and tools, find that capability or that library or that source code, and they're progress from there, again, with that sort of federated ownership and control. And then finally, we have a security team, a central security engineering team, especially on the proactive, what we call proactive security or AppSec, which does run a lot of the central tooling to make sure that we're, again, using and consuming and deploying systems and code in a very safe fashion across the board, including the open source components. And so the central security engineering team not only runs a lot of the security checks on that central central builder environment and maintains both proprietary and third-party and open source security scanning tools and so forth. They run, for example, this is a little off the topic, but a canary service. So when you write your code, you also write security invariant types of checks, which then the security team has a service which runs those constantly to make sure that certain security invariants of your service in production are constantly doing the right thing, returning the right result, the expected result from any call, typically around authorization, but lots of other security invariants that you want to maintain. You build essentially tests that run constantly against the production environment. Kind of helping hold this all together is our open source program office. They provide a kind of the general interface to sort of the correct and proper and healthy interaction with the outside world, along with David's team as well. They're the ones that are doing things like making sure that we have good relationships with the right outside builders, sponsoring and funding things that make sense. We'll talk more about security-related funding later in the talk. And in general, creating that healthy interface between AWS and the broader open source community to make sure those lines of communication, those relationships are there to support the overall health of this environment. And again, using open source in a secure fashion. And we'll talk in a minute about working upstream. So another aspect of all this is if we do see need to make changes or improvements or security fixes, what have you, a key part of what we're going to be doing is making sure that those get pushed upstream as well. So after a little detour, if you will, although a very important one on consumption, we'll go back to sort of how we think about how we interact with the broader world in open source. And we'll focus on these three pillars. Work upstream. That means when you're working with something where you're not the kind of primary creator, make sure that you are interacting with that original source in a way that is responsible and contributing to the common good there. Release tools, and effectively this is be the upstream in many cases when you have things that the rest of the community can benefit from, put them out there so others can benefit. And then we'll talk also about financial support as well. We'll start with the work upstream. So we can, if we take this kind of long-term and community-oriented approach to working in the open source world, we can benefit not only ourselves but the broader community. And we've been doing this for a long time, and increasingly more and more over the years. I'll dive into a few of these. We'll dive into a few of these examples in more detail, but just to cover a few that in a more kind of quick and anecdotal way, I want to call out Zen project. This was, as David mentioned, EC2, one of our first and most foundational services, originally launched on the Zen hypervisor. This is back in the days when Intel processors didn't have support for hardware virtualization, and people may remember some funky things that were done in those days. Zen was really pioneering with this notion of paravirtualization. Raise your hand if you remember paravirtualization. It's kind of dead, and it needs to be dead because it has some issues, but it did an amazing job. And we worked very closely in that world of Zen to make sure that we were deeply involved with improvements, patches, and so forth. Now we've been gradually deprecating our use of Zen, as probably many of you know, and moving to KVM-based, the Nitro hypervisor. We're still active in the Zen community. One of the last kind of major contributions we made to Zen was in the Spectre Meltdown era, when we realized that a lot of shared state at the processor level could lead to certain kinds of side channel issues, and paravirtualization in particular was very problematic in that regard. It was very problematic that the kind of shared state between the kernels and drivers and the paravirtualized instances, that you could have problems of the type that are manifested in Spectre Meltdown. So we actually created an internal technology to create a kind of shim layer so that the operating system that's being hypervised thinks it's being paravirtualized, but actually there's an HVM hardware virtualization layer sort of under the cover. So you're essentially creating a sort of fake copy of some Zen internals on the VM side, and then actual HVM capability between the guest and the hypervisor. This is a technology we call Vixen. And we did push this upstream, and so now any consumer of, it was modified slightly, but it did become kind of the standard now so that Zen users can run old-fashioned, never updated operating systems that expect paravirtualization, but actually are using hardware primitives to do that. There's many other great examples here before we get into some of these others. The one other one I want to call out very recently in the KVM world, those of you who are familiar with operating system and hypervisor security, you might be familiar with something that Microsoft calls virtualization-based security. So for the Windows operating system and the Hyper-V hypervisor, they've developed some technology that they could sort of take parts of Windows and run it in a separate, kind of like a separate VM. It's not exactly a separate VM, but it's a hypervisor protected memory space. And that is designed to protect against certain kinds of cross-process attacks, essentially, that might cause trouble with the things like the local security authority in Windows LSA, which maintains all of your passwords and clear text in memory, for example. Now, the problem is that that's a proprietary Microsoft technology. They released some information about how they did that, but it's definitely not open source. We developed a VBS capability for KVM, which we just recently have started pushing upstream. So anyone who uses who's in the Linux ecosystem using the KVM hypervisor will be able to run these sort of advanced and proprietary Windows features and do that on an open source basis. So we're very excited about that. Let's move on to some specifics here. We'll start with OpenJDK. So we've had a long history with Java. We're a big Java shop, continue to be. And back now 5 years ago, 2017 timeframe, began to see a future in which we really felt the need to take a lot more ownership for Java and our use of Java. And in the 2017-2018 timeframe, realized we're not the only large enterprise that is a little bit concerned about the future of OpenJDK. There was a change of ownership, as you may recall, in the industry. I won't name any names of the Java environment. And there's a general concern that the open version might need some additional love and care and really become more of a full community effort. So we joined in that effort. We created our own Java distribution we call Corretto. And since then, we've really invested heavily in the OpenJDK world, and we release our Corretto capabilities and runtime for the world for free. You're welcome to use it. It's fully supported by our support organization and by our engineering processes. I won't go through all of the different things on the timeline for the sake of time. You can download the slides. But basically, it's just the point is we're making is that we've decided to really help the community jointly own the destiny and the quality and the features of OpenJDK going forward and making some very, very deep investments in that. And I'll hand off to David for some more topics.
I just want to call out, Corretto has done amazing things for our customers and for the users. Specifically, we just saw New Relic tell us that Corretto is the most widely consumed OpenJDK distribution, which is mind-boggling, but it tells me that customers are actually finding value in what we're providing. So I'm super excited about that, but I'm a little more excited about Rust. And how many folks know what Rust is? Okay, so Rust is a new programming language. And I say new, it's been around.
David, does the world need another programming language? The answer is.
And more security tools too.
Yes, it actually does, and he'll explain why.
So Rust is a new programming language, and I use the term new relatively. It's certainly newer than C and Java. And it has come about offering the performance of C, but with a number of additional assurances. So the biggest value from a security perspective that we see with Rust is thread safety and memory safety. And we're going to talk a little more about memory safety in a little while. But when we were looking at operating things at scale, Mark said we're a large Java shop, and we started paying attention to Rust in 2017. In 2018, we shipped Firecracker, which was written primarily in Rust, and that is an open source operating system that's really permitting serverless technology. So if you're running AWS Lambda, Firecracker is there. We've released that as an open source project for people to consume. And that was the first visible notice that we gave the world that we were paying attention to Rust. We had been using it for some internal things already prior to that. More recently, we launched a new Linux distribution called BottleRocket. And BottleRocket is heavily Rust language focused and is designed to provide a really thin, small security surface for running containers. And so we've also made that open source. Folks can download and make use of that already. In 2019, we announced that we were sponsoring the Rust project. In 2020, we started hiring a number of Rust maintainers because we recognized that Rust was going to be important to how AWS was going to develop in the future. So we started building up a team of folks who were already invested in the Rust programming language, who had already made substantial contributions and had leadership positions there. Shortly after that, we helped found, with a number of other stakeholders in the community, the Rust Foundation. And today, EC2 looks at Rust as its language of choice for security-sensitive applications, such as Nitro enclaves. And so we think that Rust is incredibly important to what's going to be the future of a number of different workloads inside AWS. And we're heavily working, we've got 2 teams who are focused on upstream contributions into the Rust programming language, because we think that there is so much benefit, not just for AWS and how we build our tools and our services, but for the rest of the world, because we get into things like memory safety. But Mark and I, we just talked about programming languages, and I won't talk about a third, because maybe the world does finally have enough programming languages. I want to talk a little further up the stack with Kubernetes. And Kubernetes is really a workload orchestration that the primary workload is containers. And it has become incredibly successful. And it's become successful by a number of different measures. The number of people contributing. There are literally thousands of people who work on every single release of Kubernetes. The number of workloads that now assume that Kubernetes is going to be the underlying layer that they're operating on. And I can't tell you the number of new tools that I look at that presuppose that they're going to be operating in a Kubernetes environment. We obviously recognized this when our customers were telling us that Kubernetes was important. We have the EKS service and obviously provide managed Kubernetes. But we recognized a need really early on that we needed to get involved in Kubernetes and the rest of that cloud-native computing foundation arena. And so we've been getting involved in places like Containerd, etcd, nerdcuddle, all of the surrounding technologies that help make Kubernetes so useful and so helpful. Because Kubernetes is not just one thing. It's essentially using a driver model, allowing people to plug in different things like different network controllers, different scheduling technology. And that is one of the reasons that it's been so successful, is that ability to plug in things. But that means lots of help is needed on the outside. So etcd, Containerd, et cetera, are contributing technologies to that success. And we have heavily invested there, taken leadership positions in technical steering committees, in the governing board, and a number of other places. And also released some of our own tooling where we recognize gaps that our customers are pointing out to us. So Carpenter was recently released, a year ago, was recently shown and provides a lot of value for our customers in trying to scale things on Kubernetes. But we also recognize that Kubernetes does not exist on code contributions alone. So we've done a couple of other things. One is, despite how popular Kubernetes is and how fast it's innovating, that's creating some upgrade fatigue with customers. And so they don't want to upgrade every 6 months. They've asked us for help, and we, along with others in the community, are working on figuring out a longer support time frame for that. Because customers want to be able to actually operate something, not just be in an infinite upgrade loop. We're also, though, realizing that there needs to be infrastructure to actually test Kubernetes in advance. And so we committed millions of dollars in cloud credits every year for continuous integration, for the types of testing that ensure that when you deploy a new version of Kubernetes, that hopefully it'll be pain-free. We've been doing that as well as helping with their release infrastructure now and getting involved there to make sure that, again, the project does not sustain itself on code alone. But that's not the only thing we should be doing, right? We talked a little bit about adding features. Mark talked about adding features to KVM, improving security on Xen, and that's important. And I think that AWS has an obligation or responsibility to release the security improvements that it has. And Mark, do you want to start talking about that?
Yeah, so in many ways, again, as a shortcut, you could say, work upstream is one thing, be upstream is another thing. Of course, there's an overlap and a dynamic quality to that. But in this case, what we're saying is we have developed technology from scratch that we realize is very useful I say from scratch, I'm sure there's open source libraries inside of those, but basically, significant major projects that we then want to release to allow others to benefit from, even when they're not using our cloud platform or any of our tools. And so we want to talk about a few of those in this session as well. We'll dive into, I think, 3 of those, but I'll call out a few that don't have their own separate slides in this overview slide. So launched from August of last year, Open Cybersecurity Schema Framework, OCSF. This is actually a set of supporting open source tools, but the core release is actually of a standard which allows security tools to interoperate in a much more seamless way. When we would talk to customers and working with a lot of partners in the security space, what we heard over and over again was, my security teams spend too much time on data munging and data cleansing. They're doing this kind of repetitive stuff. They're writing tools or they're doing manual things. They're cutting and pasting between multiple open windows on a screen, just crazy stuff to try to get security tools to actually work together and to do that basic kind of function you need to do often, which is I needed to do sort of a join across 2 data sets, and it was often very, very hard, if not impossible. So what we realized was if we could create a standard for how tools communicate with one another, there'd be a huge benefit to that. So now we launched this last August, actually at Black Hat with about 20 other partners, all signing up to support OCSF. Now I think there's up to 60 or 70 companies who are all committed to either emitting or consuming OCSF records from their security products. And that will make it much easier going forward for security teams to manage the data that's flowing in and out of these tools. We also use the OCSF format as the native format of the Security Lake product that we just launched, I think, a week ago and was in the keynote yesterday. So any tool that can emit OCSF can natively feed their data into our Security Lake. And that was not an accident, by the way, that we worked on both a standard and a service together that supports the standard. So that's I think, a really interesting and impactful one. David already mentioned BottleRocket. BottleRocket you could think of as a secure Linux distribution focused on container security. So for example, it has a read-only file system. There's no reason why file systems need to be updated at the OS level if the only thing it's doing is running containers that are running virtualized file systems on top. So, and it has many other such attributes of very locked down, very secure Linux foundation for running container environments. Firecracker, we already mentioned. Firecracker is implements a technology that are called micro VMs. So again, we don't trust container boundaries as a security boundary. In general, there's a very bad track record of containers being fully secure in terms of the ability to escape from a container. They really weren't designed for that, so there's no blame there. So we strongly believe in using hardware-based virtualization whenever you have a multi-tenanted or any workload where you need strong isolation. The problem is that VMs a typical virtual machine takes a while to boot, seconds, maybe a minute, because they're big and complicated. So Firecracker implements a micro VM technology in which a full KVM virtual machine can be booted and executing user space code in less than 1/8 of a second. So 125 milliseconds is the design goal for Firecracker. We've met that consistently over time. And that means that you can now launch VMs as quick as you can launch a container, essentially, or close enough that you can use that as a very foundational property of your container-based or function as a service workload. So we use Firecracker underneath Lambda and underneath our Fargate service. But we also release it to the world, and there's a lot of other vendors now who use Firecracker in their container runtime environments. And we're really excited for the success of that. I think you're going to call one of these out before we move on. Yeah, you've got a favorite.
I do have a favorite on this slide, and it's trusted language extensions. So PostgreSQL, the open source database, has a wonderfully vibrant extension community. And that allows Postgres to change from a relational database to a vector database to something focused on geospatial and a host of other things. There are literally hundreds of extensions to PostgreSQL, the database itself. And we recognized from some of our own pain, and while it didn't directly impact our customers because of defense in depth, we saw that a number of folks were calling out the extension space as an attack surface that would allow them to do nefarious things to PostgreSQL databases. True in hosted environments as well as self-managed. And so we created trusted language extensions and released that as open source. We did that at reInvent last year. And I'm excited about this because not only does it solve a problem for us, and we could have just solved that problem, but we released this because we recognized that everyone should have a more secure and a more safe PostgreSQL. So the trusted language extensions are probably my favorite thing on this slide because it's something that we've seen a significant problem, identified that problem, and then worked to not just shut down the specific issues, but to create a safer environment to run those extensions in. I'm super excited. I'm really excited by seeing how many people are adopting trusted language extensions as the environment in PostgreSQL that have nothing to do with AWS.
That's awesome. It's a great story. So we'll dive into a couple of these. Open Quantum Safe is called out here, OQS, and we'll talk about that in the context of S2N and some other crypto stuff, and then Cedar, and maybe I think we have one other example here in terms of our decision to work in the open with core technologies that we develop. So you can imagine you run a cloud platform, encryption, super important. It's one of the fundamental properties of data isolation, data security that customers rely on, that we rely on. So you really want to be constantly on the cutting edge of cryptography and of encryption technologies across the board. Customers, obviously, they're running applications on top of our stack. They want, super efficient systems with minimum CPU and memory utilization, but they want state-of-the-art technology underneath. So we've been on a journey now for a number of years to develop technology in this space and to open source the technology we develop because we believe it can benefit the broader community. I'll start with S2N. S2N was one of our first forays into this general space. It originally stood for signal to noise. I'm not sure if we even spell that out anymore. We call it S2N. But you can think of S2N as a very stripped down, very minimalistic, very feature poor, intentionally, implementation of the TLS protocol. Feature poor meaning that TLS has a ton of features that most people never use. But to implement those features takes a lot of code and therefore introduces the possibility of more bugs. This is the wake-up call for us, and I think for a lot of people in the industry, was the Heartbleed 0 day. Remember the Heartbleed one? Raise your hand if you had a bad day on Heartbleed day. We did too, although we were able to patch a massive global fleet of load balancers in less than 24 hours. We still had literally hundreds of thousands of hosts that had to be patched in our ELB service. But that was a wake-up call because we looked at okay, what's the root cause here? Well, it was a bug in OpenSSL. And okay, software has bugs, but that was a pretty painful one. But what about OpenSSL? Oh, it's 300,000 lines of C code. It's old. It's crufty. It's got, God bless the community for keeping it up, and we've been financially supporting them ever since. And it's done a ton of good for the industry, but it's not what we felt really good about in terms of relying on as a core technology for very fundamental security properties of our cloud. So since then, we've been kind of on a journey to both implement a replacement and substitute that in and use it, as well as release that to the world. S2N was one of the first steps there. So it's again, just implements the TLS part of the protocol, still uses OpenSSL for the cryptography parts of the handshake and the encryption. That was some years ago. S2N is an interesting example too, because this was before Rust was kind of up and running and popular. So it's written in C. However, it's written in a very strange and idiomatic C that looks just like Rust, because you can't do any direct memory access. It requires all these kind of indirections. And we have formal tests and proofs that show that if any developer does a check-in that's not using the proper memory handling functions that are inside of S2N, sorry, your code will get rejected. So still using the C language, but using it in a very carefully crafted and memory-safe fashion. A couple of other really interesting facts about S2N. First of all, it's a project that had, I think at the start, maybe a little bit more now, about 20,000 lines of code, 80,000 lines of tests. So it's a very, very test-centric, test-heavy project. And it was the first release to the wild, as far as I know, at least of any significant piece of code in which formal verification was part of the build and the test and release process. So all the people we hire, and you've probably heard in many talks from AWS, a group we call the automated reasoning team, or these formal verification capabilities, a branch of computer science that has been a bit obscure, has been around for a long time. It's not obscure anymore, at least as far as we're concerned. We're using more and more, we're using the tools and techniques of formal verification to prove the correctness of code. In S2N, if you go to the GitHub repository and you look at the build instructions and you download and try to build it, you're going to actually download a bunch of formal proofs about the correctness of various parts of that code. Again, it doesn't mean the code's bug-free necessarily, but it's a much higher standard than we've traditionally done for a lot of these systems. So that was a big and important foray into this space. But we didn't want to stop there. So subsequently, we've also open sourced our own libcrypto. So now we're giving you an open source re-implementation of the core cryptographic primitives you need for your network, as well as other use cases that are traditionally done in the OpenSSL library. I won't go on and on about libcrypto, but it's out there. One of the key things we're doing with libcrypto is we're taking on the burden of FIPS validation. That's one of the kind of things that people often expect of their cryptographic libraries. They want that third-party validation. And interestingly, even around the world, we still hear people are very happy with FIPS validation, even though it's technically a US government standard. But it's hard for an open source team to do that. It's expensive, it's time consuming, it's frustrating, it takes a long time. You almost kind of require commercial interest and commercial commitment to really kind of go through the trouble, which many companies do. But we're doing that on behalf of the open source users of S2N and of libcrypto. We're taking that through FIPS validation, and we'll keep that up to date as time goes on, which is kind of the hard part. Often you get it through and then you kind of like relax and move on, and then your code gets out of date, and so you get into this bad cycle. So we're doing that with libcrypto. And the final thing I want to call out that's just briefly referenced in this slide, and we could spend a whole hour on, is post-quantum cryptography. So we've made a lot of investments in PQC. Again, the nutshell version, which I'm sure most of you know, is nobody has a sufficiently coherent quantum computer today to crack asymmetric cryptography, but all the experts say that if we can invent one, and we don't usually like to bet against engineering teams, once problems go from theory to engineering, the engineers are often very good at succeeding at very hard problems. And so it's not unlikely that in the future, not too distant future, there will be a sufficiently powerful quantum computer that could crack today's asymmetric cryptography. Now, the good news is often not mentioned, which is symmetric cryptography does not suffer much from quantum computers. So if you're using AES-256 for encrypting something that you write to disk, as EBS and S3 and Dynamo and all our storage services do, quantum computers would speed up brute forcing of that, cracking that crypto by a factor of 100, 1,000, doesn't matter. There's so much power is required to crack those that's essentially irrelevant, at least as far as we know, according to today's experts. But asymmetric cryptography, totally different. It's very susceptible to being cracked by a quantum computer using brute force techniques. And therefore, we have to get ahead of this problem before it becomes a problem. So we've made a lot of investments in post-quantum cryptography. We have production systems today in production using hybrid key exchange, which means that it encrypts the inner keys of a TLS session with both elliptical curve and post-quantum, so that if one is cracked or the other, you still have it's basically defense in depth. So a lot of really interesting technology going on in there. But again, the key thing is we're doing this in the open so that anyone can benefit from all the investments and the work that we're doing in this space. Speaking of formal verification, because that's one of the key sub-themes of this open source release, which we just made a month or so ago, we've introduced to the world another new language. Hey, we need new languages. We really felt we did need a new language in this case. We looked long and hard at existing authorization languages. So this is a kind of narrow but very important part of the security world, is how do I encode permissions about access to systems? If I could step back, for those of you like me who have worked in sort of identity and access management over the years, as an industry, we've done a pretty good job on the identity side, right? We have a pretty good story about SAML and OIDC and blah, 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 that allows me to come across into a system with some sort of validated, cryptographically validated user with a set of claims. Okay, now I show up at a system. Now what happens? Somebody has to make an authorization decision, like what rights does that person have in the system that they're accessing? There, the industry has done a terrible job of standardization. We tried years ago with something called XACML. If you know what that is, boy, we could go have a cup of coffee and talk about that. Failed miserably. And if you think about today's IT systems, on premises especially, you have these ACL models everywhere, SharePoint ACLs, Exchange, different file systems. Everything has an access control model that's all completely disjoint, completely heterogeneous, and it's not a good story in terms of wanting to understand and answer those basic questions. Who has access to what? Like that is the holy grail of access management systems. Who has access to what? Today, super hard to answer that question. It's easier in the cloud, by the way, because you have a common identity management system for all the APIs. Still not super easy to answer, and we're getting there, but at least there's a possibility because of the unification on the access side. But, long digression, but we decided that our existing IAM system works great, but was it the right language to expose for a broader set of use cases? We decided not. I can go into lots of gory details why not. We looked at existing open source or standards technologies. They didn't really meet the requirements. So we invented a new one called Cedar. And there's many great things about Cedar, which I won't go into, but one of the most interesting things is it was built by a joint engineering team that included both experts in access management, but also formal verification scientists who built both the language for formal verification, as well as the implementation, the runtime, and the libraries. Those are also formally verified, because you really want correctness when it comes to access decisions. So this is a really cool technology, and there's some great blogs on Cedar if you want to dig into the gory details. It includes another technology called differential testing, which is a very interesting sort of probabilistic fuzzing, if you will, because even with formal verification, you still want to do some testing to make sure that your tools are all working properly. So enough on Cedar, but it's a very exciting release, and we hope the world adopts this and uses it everywhere, because even though there'll still be some challenges in terms of unification, having a common access language would be a huge win, and we're working hard to make that true.
Yeah, Mark, I was one of the naysayers who said that there was no need for Cedar because we had other access languages out there. And when this project came up internally, I was one of the folks who said, why are we reinventing the wheel? This doesn't make sense. But the formal verification of both the engine, the access engine, and the policy itself really sold me that this was something new that actually needed to exist. I'm excited about Cedar. I'm excited about the attention that it's getting as well, because people seem genuinely excited about this, and those people are not even AWS customers. They're recognizing that this is a gap that we have in the security space. So I want to talk a little bit about SnapChange, which was another open source release we made last month. And SnapChange came out of a team inside AWS called Find and Fix, or our F2 team. And to explain a little bit about what F2 does, the F2 team has a mandate that they are to go look at what AWS and our customers are using the most, and then to audit it, to find problems, specifically security problems, in the most commonly used open source tools that AWS and our customers make use of. And they've been on this journey for roughly a year now. They've built up a team of security researchers, and they're trying to figure out how to scale up their capacity to find problems. And SnapChange is a fuzzing tool, and fuzzing essentially tosses a bunch of strange inputs into various breakpoints in a piece of software. And frankly, fuzzing as a general tool has been responsible for finding lots of problems. And they looked around, they're using plenty of fuzzing tools as it is today, but when they looked, they said, there's some things that we can improve. Specifically, SnapChange is a tool that works in an emulator or a hypervisor environment. It presumes that the software is actually going to be running as a virtual machine. And it is able to inject the fuzzing via that layer. And so I said, why are you doing this? There are already tools that do this. And one of the call outs was, well, those tools today require a modified KVM and are a modified kernel. So you've got to load a specific kernel module that does not ship in tree. And that's a barrier to some folks for being able to easily deploy this, being able to run it at scale. The other thing that they wanted to do is they wanted to scale this across multiple cores. And so multiple CPUs at a single time and run that, allowing folks to hopefully scale up and make their fuzzing activities a little faster. So SnapChange allows folks to basically use breakpoints in code and submit all of this fuzzing data into the program and to replay that. And so dramatically more scalable and hopefully faster for folks to use. This is really targeted at the security researcher audience. This is not something that we would expect an average developer to go make use of. We're excited about it because the security community seems to be finding this useful. And I'm really excited that this team is getting a little bit of visibility because they're doing amazing things in terms of finding bugs, because their mandate is both to find and to fix. They're not just looking at bugs that they're finding in code and saying, hey, here's a security vulnerability. They're developing proof of concept, they're developing a patch and shipping that to minimize the workload on the open source maintainer. Because we don't want to stand up a team that basically creates a denial of service, a social denial of service attack on open source maintainers. So we want to provide them as much help as possible when we're going out and looking for security vulnerabilities.
I'm going to interrupt you for a second, go slightly off script, because I think this is super important and something I learned from you when I first started getting involved more in open source security. So by the way, David is the president of the Apache Foundation in his spare time, and very, very long and deep involvement in open source community. And I remember when we first started talking about these kind of security audits and so forth, you sent me this post-mortem of a security audit that was done on some Apache software. And it was so enlightening because what it made me realize is you can go in and you can find bugs. There's no problem finding bugs in large software code bases. Now what? Bugs, okay, great. Now what do I do? Where's the resources that are needed to fix the bugs? That's a whole different thing. And it's also very hard to inject those resources, even if they exist, into an existing development team, an existing culture, an existing way of building and developing software. So I found that super enlightening, and it was also kind of an eye-opener, like it's not a matter of finding bugs, it's a matter of creating this virtuous cycle of finding things, but also developing the skills, the capability of the community that owns the software, prioritizing those fixes. All those things are a much harder problem than just finding things, and I think that's a super important story around how we need to, as a community, get better at doing this stuff.
I think that report that you mentioned was talking about all of the influx of help that happened after Heartbleed. And I use help in air quotes, right? Because security is not a one-time thing that you can say, all right, we're secure today, and then walk away. It requires that continuous investment where you're making long-term investments in not just technology, but in communities, and making sure that you can actually shift the culture, shift the practice to something more secure. It's not. You're right. It's not about finding bugs. If it was that easy, we'd be much better today. We would probably not be giving a talk today on open source security. So I said this earlier, but open source projects do not work on code contributions alone. And we think that AWS, you can see it in our leadership principles, size and scale bring great responsibility, and we certainly have a responsibility to open source. And so we recognize that, and one of the mechanisms that we can make use of is to support a number of open source projects and open source foundations. And we do this across a number of places. So we support places like the Python Software Foundation, the Apache Software Foundation. We're members of the Linux Foundation and Cloud Native Computing Foundation, and provide a baseline of support via that mechanism. That provides us a way to make sure that that base level human infrastructure is in place and that people are able to get things done. But I want to dive into how we're thinking about funding security responsibilities, because I think that is a separate layer above just funding the open source projects themselves. So the Python Package Index. If you're not familiar with PyPI, it is a...
You're not a Python developer if you're not familiar.
You aren't. You aren't. This is how the world consumes Python, right? It is the package repository. If you're a Java developer, there's Maven Central. If you're a Python developer, there's the Python Package Index. And it is a huge attack surface for folks trying to impact the software security supply chain. And we recognized this early on, paid attention to it, started working with the Python Software Foundation, and said, what can we do together to improve this? And they said, well, today we're doing mainly reactive response to security issues. We don't really have a great security strategy for the package repository itself. We're not proactively going out and looking for threats. We would like to change that. They put together a proposal and brought that to Mark and I and said, hey, this is what we'd like to do. Can you fund this? And we said, absolutely. This makes perfect sense. We'd love to jump in here because we consume packages out of the Python Package Index. All of our developers who are doing Python do that. Our customers do as well. And so does the rest of the world. You're not developing in Python if you're not using this. And so we have been working with them to help create proactive strategies, build up some internal staffing so that they can actually respond to issues timely. And we're not depending upon volunteers in Nebraska to respond to a security issue in the Python package.
You must have some individual in mind when you refer to, so we won't mention any names.
we won't mention a comic's name. But we're not responsible if we're not taking into account these distribution points and making sure that we are helping to fund their security, because that impacts all of us. We have that shared destiny we talked about earlier. We've also, and we've hinted around at this a little bit earlier, but there's a number of scholarly articles written by people far smarter than I that are looking at the overall timeline of security vulnerabilities. And they're reporting that 65% of security vulnerabilities in the past decade are memory related. 2/3 of security vulnerabilities are from a single class of security threat. And one of the reasons we are so interested in Rust is that it provides tooling to ensure memory safety. Now, that's not a panacea for, Rust does not make you magically secure, and I don't want to paint that picture. But it is a much more assured position from a memory safety perspective. And I'm excited about that for what we're developing internally, Mark, but we looked at where some of the entry points in terms of open source was. And I remember us sitting in your office in Virginia a year ago now, almost, and talking about the places where we were seeing attacks and seeing security vulnerabilities in open source. And again, security is not a point in time thing that you can go say, I'm secure today and I don't have to worry about it anymore. And so we looked at where can we focus on things that are on a network boundary, things that are getting lots of direct internet traffic, or they're parsing huge files. How do we go address that? And so we identified 4 initial projects and asked the Proximo project out of the Internet Security Research Group to go rewrite those for us, and we provided funding to rewrite those. So those initial 4 are the NTP daemon. We asked for a Rust implementation of that, sudo and SU, because again, increasing your authorization level is something that you really don't want to have memory issues in. Rustls.
There's a long and sad history of bugs in that.
There are a lot of memory bugs specifically in sudo. Rustls, the TLS library for the Rust programming language. We wanted to improve how fast Russell's was going to be able to be production ready. We want to make sure that Russell's is already written, so no inherent rewriting, but we want to mature that rapidly because we think that a TLS implementation that's memory safe is super important. If your encryption fails, you've got lots of other problems. And then an AV1 decoder. And AV1 is itself an open source success story. And we wanted to make sure that, that this decoder that's processing lots of huge files, both audio, video, and images, is written well and is secure. So we've been investing in a lot of that. And finally, the industry as a whole has coalesced around the Open Source Security Foundation. And Mark championed joining OpenSSF years ago, right after it came out. We joined that. We started investing and spending time there. Folks from Mark's office were certainly heavily invested in trying to advance the state of security in open source. But we recognized that there was opportunity to do more. And so last year, we committed $10 million towards OpenSSF to make investments in long-term, sustainable open source security initiatives. And we did a couple of those. I'll talk about them real quickly. Alpha Omega, which has two objectives. The first is paying attention to the 10,000 most widely used open source components and creating automation around finding security vulnerabilities and patching it. So they're really heavily focused on automating security as much as possible. The other side of Alpha Omega is focused on the top 100. What can we do that has outsized impact across the most heavily consumed open source packages, and how do we make that security investment sustainable? They're doing great work. We're seeing lots of things happening there in a number of different communities. We continue to be excited about that. Security scorecards, though, Mark talked about consumption, right? And we at AWS, we delegate open source consumption decisions to builders. Nobody comes to Mark asking for permission to use another programming language, even though he's in the security organization. Nobody comes to me in the open source organization saying, I want to use this thing, is it okay? An individual developer is doing that. And we think security scorecards, which will provide an automated look at a number of health metrics and security metrics, provides much greater information to base decisions upon so that those developers who are deciding what open source they're consuming can make better informed decisions. We're excited about some of the work coming out of security scorecards and look forward to that being more ubiquitous. And of course, we're doing a lot of general support as well.
So let's close out our session. And just as a reminder of our takeaways and our pillars, work upstream and contribute to the open source world and provide financial support. And for all of these things, we encourage you, the broader community, to join with us in these areas. Think about ways in which your organization can work in one or two or three of these ways, or come up with new ways to work to support open source. Join with us, come to us with ideas. We're very interested if you have funding ideas, if you have engineering ideas that you think can help in this world. That's super, super important. We're going to join together to make the world a safer place because we all depend on secure open source. And we thank you very much for coming, and have a great rest of your time here at re:Inforce. Thank you.
Thanks.